First, we took two 50 milliliter beakers from the container shelf and put them on the workbench. These are the two beakers in which the solutions will be placed.
Next, we took sodium hydroxide from the material shelf and added 15 milliliters to one of the 50 milliliter beakers. Looking at the solution, you notice it is slightly gray and relatively clear. We then renamed the beaker sodium hydroxide.
Then we took nickel 2 chloride from the material shelf and added 6 milliliters to the empty 50 milliliter beaker. This solution is bright neon green. We then renamed the beaker nickel 2 chloride.
We can now zoom in to see these two aqueous solutions that will soon be combined. The clearer sodium hydroxide is in greater amount and thus the solvent. The neon green nickel 2 chloride is in the lesser amount, so it is the solute.
The nickel 2 chloride is then emptied completely into the beaker containing the sodium hydroxide. The reaction is immediate and a bright green precipitate, similar to the color of the nickel 2 chloride, is formed in a very small amount. The precipitate is sitting on the bottom of the beaker in a clear liquid similar to the color of the sodium hydroxide.
It can be concluded this reaction is a precipitate reaction. This is because the cations and anions in the aqueous solution combine to form an insoluble solid, or precipitate. This is the bright green solid sitting at the bottom of the beaker.
This is the balanced molecular equation in which aqueous nickel 2 chloride and aqueous sodium hydroxide combine to form the solid nickel 2 hydroxide and aqueous sodium chloride.
This is the total ionic equation showing the electrolytes and aqueous solutions broken up into their separate ions. The precipitate nickel 2 hydroxide in this equation is not broken up.
This is the net ionic equation showing the cancellation of spectator ions. All that remains are the two aqueous ions that form the precipitate nickel 2 hydroxide and the product nickel 2 hydroxide.